All right, good morning. Happy e-learning Friday to you guys. So today we're going to take a look at non-disjunction. So quick notes, and you guys will have a homework that goes along with it. I think it's a lab activity actually that you're doing today. So, all right. Oops, forgot what unit we're on here. What was our last one called? 10.5. So this is 10.6. This is our last unit and last chapter in unit 10. And what we're talking about today is called non-disjunction. Non-disjunction. It's a topic of conversation today. And the idea, the concept here is so the failure of chromosomes to separate properly is called non-disjunction. So disjunction sounds like separation, right? Disjunction, just joining, they're separating. So non-disjunction is when it doesn't happen. Generally, we'll be looking at meiosis. And non-disjunction occurring in meiosis. And it can happen in one of two places. Blue pencil is in my hand. Here we are. Found it. We are. All right, so the first place that non-disjunction might occur, so again, remember, during anaphase 1, so here's meiosis 1. During anaphase 1, those chromatids are supposed to separate. The homologous pairs are supposed to go in opposite directions, but what if they don't? What if these two just, for whatever reason, they don't separate, they stay in their tetrad form, the spindle fibers don't attach properly to one end, and they both end up getting pulled? That's way too big of a cell, sorry. Should be half that size, not twice that size. And now you end up with both your dark chromosome and your light chromosome over here in this half. Those blue homologous pairs, they both got pulled in the same direction. And over here, so we've got an extra chromosome on this side, and we have one too few chromosomes over here. We're going to assume then that during meiosis 2, the chromosomes you have remaining will separate properly, but the damage at this point has already been done. We should have two chromosomes, two chromosomes, two chromosomes, and two chromosomes, but instead, these gametes have one extra chromosome. These gametes here have one too few. So our designation for that, these two are N+1s, whatever the N number is, they have an extra chromosome, +1. And these guys N-1. So again, we're looking at our cell. The cell we just diagrammed, our N number was 2. They have two unique chromosomes, the red chromosome and the blue chromosome. And of course, they're diploid. They have a pair of each, a pair of the blue chromosome and a pair of the red chromosome. But when we come down here to the gametes, because non-disjunction occurred during anaphase 1, the homologous chromosomes failed to separate. Don't know why the word separate always gets me. The homologous chromosomes failed to separate, and you ended up with, again, some gametes have an extra chromosome, some have one too few. Place. This can happen. That's non-disjunction occurring in anaphase 1, but it could also happen in anaphase 2. So let's say we go through meiosis 1 and everything works as according to plan. The red chromosome gets pulled over here, the orange chromosome gets pulled over here, the light blue over here, and the dark blue over here. So meiosis 1 occurred as it was supposed to, but this time, what if we have a non-disjunction occur during anaphase 2? So this time, the sister chromatids, or X shape, is not going to separate. So we've got our X, we've got our two identical chromosomes, and they're supposed to separate, but what if they don't? What if they both just move to one side? Over here on this side, it's probably very unlikely that non-disjunction would occur twice during the same round of meiosis. So over here on this side, we'll say we've got some normal cells. This is what those gametes are supposed to look like. But over here, that X failed to separate, meaning we've got two blues in that one and none in this one. So this is going to result in two normal cells. These two are okay. These two work out. But over on this side, we do end up with that N+1 and an N-1. So during anaphase 2, sister chromatids fail to separate. Man, there's that E in separate again. I have got to fix that. All right, separate. There we go. So during anaphase 1, the homologous chromosomes might fail to separate. During anaphase 2, the sister chromatids might fail to separate. So there's two places that non-disjunction might occur. You see them here, two different possibilities. Quite honestly, this happens probably more often even than we are aware. If one of these cells, again, these are going to be the reproductive cells, if one of them ends up fertilizing an egg or one of them is an egg, oftentimes the embryo or the fetus never develops. So how often does it happen? We're honestly not terribly sure. There are some syndromes where people can be born with an extra chromosome or one too few chromosomes. There are some syndromes out there, and you'll actually get to read up on some of those syndromes in today's activity. So I'll let you guys get to that now. It's posted on Canvas, but that was today's notes, all about non-disjunction. Have a great weekend, guys. I'll see you again on Monday.